Hey guys, welcome back to the Radiola 60 restoration project. While we wait for the grain filler to set up, let's turn our attention back to the electronics. I did a quick look over of the two chassis when I first got the radio. We started exploring the socket power unit, and it's a little rough, it's a little nasty. Some rodents had been in this radio. I washed this down with some disinfectant, scrubbed it a little bit. We've got corrosion, the wires are crumbly. So I started working on it. I took off the terminal strip here with the thought that I would undo the wiring harness, start taking the parts out. But then I remembered something. We might have an alternative. See, some years ago, one of you, sorry I don't remember which one of my viewers, but one of you sent me a socket power unit with the thought that I could use it to make a battery eliminator for a couple battery powered sets I have, and that is a fine idea, and I may very well do that with one of these. However, I do believe they are identical. I say I believe because it's a little hard to tell at first blush. I've been studying them and I think they're the same, but they look a little different. The coloring on the wiring is a little different. The way the wires are routed looks a little different, but I think the connections are the same. The wires just don't quite run the same way. I'll give you a simple example. There are two power resistors here. On this one, these two lugs are connected together. There's a wire running right here. At first I thought this one wasn't, but yeah, it is. It's just that the little bit of wire is running over on this side, on the right side, whereas on this one it's on the left side. Similarly, I think the rest are the same. The colors being different throws me off. Maybe they were originally the same color, but they are not now. So for example, this is a pretty vibrant green, this wire here, whereas this one is rather pale. I think what's happened on this one is that goo came out of whatever this box is and stained the wires. On this one you can see there's a lot of wax. This must be the capacitor, and I believe the output transformer is in the same box. Now that's a good thing. These are not tar filled, or at least this box is, and this is the one I believe we need to rebuild. It's beeswax filled. So although you still need to heat it up and melt the wax out to let the inside slide out, it's not a horrible, sticky, smelly mess. Well, okay, it's kind of a mess, but at least it's fairly pure beeswax rather than nasty tar. However, yeah, you can really, this one's pulled up a bit too. I believe this box, you're going to be a transformer or a power choke, I believe does have tar, and it's oozed out on this one, pulled up a bit there. I think on this one it oozed out and stained all the wires, or at least in some areas. Alright, anyways, yeah, that's making it really hard. So again, on this one, this is a pretty bright yellowish wire with red tracers or something like that. On this one, everything just kind of black and brown, far less vibrant. Cosmetically, this one is better, but it has issues too. I mean, after all, these are very old. This was never a mouse house. I don't think it was. For example, this plate is still quite legible, but it is dirty. It should get repainted. But I'd rather work on this one than this nastiness. And this one is not so bad that I would want to remove this. So I am going to study this a bit more. I do believe they are identical. Unfortunately, there's no model number, but the plates, from what I can read, are the same. 120, 110 volts, cycle 50-60, 105, 125, max primary input 90 watts. I can't read the rest of that, but see license info. Yeah, unfortunately there's no model number or anything. Maybe I'm just wasting my time. Maybe they only made one socket powered unit for all the radios. I don't know. But it seems, well, And then there's this chassis. This one I'm more concerned about. The other is a fairly simple power supply. This is everything: local oscillator, mixer, IF, and output stage. It's a bit nasty, and I'm wary of being too aggressive with it because I've heard these are tough to align, and there are some areas you don't want to mess with if you don't have to. Now we've got nastiness around the bottoms on both sides, around this area. Worse on this side, but we've also got nastiness down inside the belly of the tuning caps. Down in there. One can't take this all apart. It might be hard to get them out, but there are some screws down in there. This capacitor, variable capacitor ganged thing here, is on a sub-assembly. This can come off. I'm not sure if it's newer radios. This would be rubber shock mounted. This may or may not be. Can't quite tell. There is a little bit of daylight between these two, so there may very well be some rubber mounting cushions between the two that have become rock hard. This does rotate. That's a good thing. This dial is broken. I've heard that's a common problem. It's a brass strip and it just cracked clean through. Now we don't have to clean any corrosion off. We could just pretend it's not there. We could scrub it off, a little brush, and get the Q-tips out and clean it up a bit. Just leave it. We could put rust neutralizer on it and paint over it and just forget about it. A little harder to do down here, but we can. We can get small brushes out and just, dab it in there. Which honestly I'm more inclined to do, especially because I'm not familiar with this radio and I don't want to screw it up. So let's look at the more interesting side of things. This is where all the action takes place. I got some advice online, specifically about, I think, these capacitors, to not mess with them. Especially this one looks odd. It's like 3 of them put together. Part of this, I guess, is a neutralizing circuit, and I think these caps, or at least one of them, is carefully selected for the radio, and that's why I put 3 of these in parallel to kind of build it up to the right value. I think these are mica, so they shouldn't be bad. We don't want to mess with these coils. This one has a primary and a secondary, it looks like, yet another cap across it. I don't know if that's a tunable IF or if that's the local oscillator. Inclined to believe that's the local. Well, I shouldn't say anything. I shouldn't assume anything. But what I can see, I realized at first, is that these are variable caps. We have 3 of them. This is a bit earlier than what I'm used to working on. It looks like there are 2 metal surfaces, and there's a screw here, and this adjusts the distance between them. It's a bit of fluff. That. Okay, yeah, there's a primary on this one too. Okay, all of these have primaries and secondaries. Just the construction threw me off a little bit. Here, I'll zoom in a bit. So the primaries are, it's way down at the bottom on this one. You can see it here poking out on this guy. So these two are basically the same type of coil. They're just mounted differently, probably to eliminate crosstalk. If you mount coils like 90 degrees apart or 180, it greatly reduces crosstalk. Notice these aren't shielded. They're just all out in the open. This one's a little bit different. That's why I think this might be a local oscillator. I don't know. We'll have to get out our wiring diagram and component layout. Luckily we have super detailed service info. Ooh, this got munched on. We are missing cloth insulation on some of these wires. This wiring bundle down in here. Ooh, yeah, we would not want to power this up. Ooh, and this one. Yeah, we we have our work cut out for us. Maybe these two wire ends went together originally, but they don't now. This one's almost chewed through all the way. And these two are still here, but the insulation is gone. Yikes. At least it wasn't, there's no pee or droppings down here. It's just some cloth gone from around the wires. Ooh, what's up with this? That's... Wow, could this have gone? Whew. I don't like the looks of that at all. Here's what I'm looking at. On this, there's just a stump of a wire about 3/4 of an inch long that doesn't go to anything. And I don't see a wire nearby that might have... Oh, wait, no, here it is. Here it is. It's down below. Jeez. Alright, this project just got more complicated. I didn't realize I was going to have to rewire this chassis. Nuts. Wow. That's a pain because those wires that are munched on here. Let me back up here. This old insulation, this cloth, it's so nice and brightly colored, and it's all laced up and bundled, and but the wires that go through here and run along all this chassis, those are the ones that come over here and all got munched and shredded. I'm going to have to undo all the cable lacing and replace at least some of these. And then that goes out to the connectors on the end that plug into the other chassis. So I'm going to have to undo these connectors and replace. Like, these red wires are the ones that run all the way to the other end that are... Okay, yeah, I suppose the ones where all the wire strands are present, the insulation's gone. If I could free up one end on this, I could slide some heat shrink tubing over it. I'll try that. These ones that are nibbled in half, I can probably splice them back together and again slide heat shrink tubing over it. Wow. Alright, well, let's try to focus on some more positive stuff. Here, these are all the tube sockets. Looks like they're black Bakelite bases and brass-ish. Maybe it's copper-plated steel. I don't know. Yeah, probably brass. A little bit of corrosion, but some deoxit should work great on those to clean up all those pin connections. Thank goodness it doesn't look like these coils have been munched on. I'm not sure what's inside these three brown tubs here. Probably coils, shielded, but I'm not positive. Hopefully we won't have to get inside there and find out. There's the dial drive mechanism. Looks like it uses a braided bronze kind of wire. I'm glad that is intact. Doesn't look like it'd be easy to replace. not with the original type of material. A little bit of chafing here because the grommet's gone from the end. We can replace that. The wiring insulation's a little frayed. I'm hoping we can just deal with it. I was rambling on so much I didn't realize the camera had died. The battery wore out. I'm not sure it cut off, but what I was saying was I'm inclined to patch this up and do as little as possible and focus on the power supply part of it and try getting this working. Perhaps not touching anything and just fixing up the wiring. So I've heard that guys are running these just as is on original parts. Mostly what we see here, I believe I've heard these are mica caps. Those are probably fine. Some dog bone resistors, probably off value, but maybe they're still close enough that it'll work. Hope that this big resistor back here is good. We can measure continuity on that. And I believe this and this are caps, but I've heard the way they made these back then, they're fairly reliable. We've got a huge rheostat of some sort here. I don't know if that's making very good contact. It's a little... Ooh, it looks like it broke off and somebody... Oh, let's get a closer look at that. Boy, this thing is getting more fun by the minute. It looks like this wiper may have broken off and somebody globbed it on with some solder. Could be that's how they made it originally, I don't know. But it doesn't really feel like it's making very good contact. I'm not hearing much of a scraping sound as it's going around. If I push down on it now, I can feel it's making contact. So that's a potential area of concern. I don't know if a replacement's readily available. I expect the amount of replacement would be much smaller. I don't know if there's really all that much power going through it. This thing is huge and it's all ceramic and rather complicated looking, but at the end of the day it's just a rheostat. I'm used to speaking with a bit more authority when I work on projects. For example, all these TVs I've been doing lately, I'm so familiar with them, I can just say, oh, that's that, and that's that, and this does this, and that does that. I'm a bit out of my element here, that's why I'm rambling on so much. But I hope you guys are enjoying this as I muddle my way through it and explore. That's what you find. The older the radio is, the weirder it starts looking, where parts don't look like what you're used to, and circuits are laid out more differently than what you're used to. And of course, there's also a greater chance that a mouse lived in it and chewed up the wiring. Well, I know what I need to do now, which is to study the service info and start getting more familiar with this. Now, these aren't super rare. Worst case scenario, I could probably get an entire replacement chassis if I wanted to. I mean, I could ask around online, maybe somebody's got a junker, or get some of the individual parts if I choose to go that route. But let's assume we're going to be getting this one working. Hang on. Before we go anywhere, let's power this up. This is the remnant of the old power cord. So if we power this up without any rectifier tube in there, we can just measure the AC voltages on the secondary of the power transformer. We can just stick our probes right into the 80 rectifier tube socket. The pilot light's been clipped out of this one, but we should have, I think it's 6.3 volts there. So let me grab a power cord and rig this up. Alrighty, I tacked in a power cord and I transferred a dial lamp from the other SPU. We are going to plug this in. Let's see, let's put this in the 120 position. And don't need a dim bulb tester because I have got my PR57 here. Plug that in. It's turned off right now. Everything's off. So, the capacitors will not have any voltage on them because there's no rectifier tube, so there's no DC. All we're going to be doing is feeding an AC to the primary of the power transformer, and then we can check the various secondary voltages. Now we have an 80 rectifier tube socket here. 2 larger holes, 2 smaller holes. The larger holes are going to be the filament. We can just stick our probes right down in there and we should get about 5 volts. And on the other side, some hundreds of volts, 500-600 volts maybe. I don't know exactly what it is, but it's typically what you would see. Oh, the first thing we're going to see when we turn this on, if all is well, is this little bulb here should glow. There we go. No. Alright. Well, let's see. Could be a few things. 1, let's make sure this bulb is tight. 2, maybe the power switch on this is either off or maybe it's bad. Alright, here we go. Ooh, we have glowing. We have glowage. Excellent. And we have, wow, can't ask for better than that. Just about exactly 5 volts for the filament side. Now let's go to the secondary side. Ooh, probes fall out there. I think I saw about 600 volts for a moment. Yeah, about 600 volts. I think we have a winner. Now there are a bunch of taps on here. I think there are some lower voltage tubes in this, so I can check those. But I was told this was good, I believe, when I was sent it some years ago, and this is a pretty good indicator. Now, a few other tests I could do. I could let this sit for a while and see if the power transformer gets warm. Should be an indication of some breakdown on some of the windings. I can check for resistance between, say, the chassis and all the windings to make sure there's no leakage current going through anywhere. But I'm feeling pretty good that this is good. These are pretty over-engineered and they're pretty reliable, and they're fairly simple. So I think we're good. All right, so I am gonna continue checking. I want to check the power resistors down below, the big tapped ones, make sure that they're all good, and of course make sure that this is compatible. I'm pretty darn sure it is, though. Alright, now I'm going to end this video. Thanks for watching.